All right, welcome to another, I guess just a supplemental video. By supplemental, I mean extra, right? So it's really nothing like new from class, but it might be something from class that I either expect you already be familiar with, or I don't know. It maybe I expect you to already know it, or something, right? Or pick up on it quickly. And sometimes, that doesn't happen. That's okay, right? Sometimes we forget things. Sometimes we just got to hear information again to process it again, So the question we are going to address in this video is, what is an asymptote? Okay, because I've been hearing a few students saying they're not quite sure what this really means yet. And you know what? Can I change this to graph paper? Let's do that. Can I do that? Boom. Yeah, I can. Awesome. So I'll be working on graph paper here. So we've talked about an asymptote. I gave a definition. In class, I said something like, definition, an asymptote is a line that the function, and I'll put in parentheses the curve, right, the graph, approaches as it goes towards plus or negative, like positive and negative, infinity. That's what an asymptote is, okay? Now, if you Google that, some of the popular results are going to say an asymptote is a line that the function gets close to but does not cross. And that is false. Mathematician teachers lie to you when they say that. And they tell you that because I guess it's easier to learn that first and then go back and, whatever. But I mean, why would I lie to you, right? It doesn't matter about whether it's really crossing or not. It's about the ends. That's what an asymptote is about. You're looking at the ends, the right end and the left end of the graph. If it crosses it somewhere in the middle, whatever, I don't care. But at the ends of the graph, it's not crossing, right? I guess even then, it kind of could. But the idea is you are getting closer and closer and closer to a particular number, but maybe never arriving. Right? So, yeah. Gosh, I wish I could remember the function example, but I guess I can draw it even if I don't know the equation. So, I'm going to draw a couple examples of asymptotes. We have three functions that have asymptotes. The first is exponential. Make a nice straight line. Thank goodness this app makes straight lines like that for me, because I would be lost if I could not. So the first is exponential, and I'll say something like 2x. And by the way, it doesn't have to be 2 to the power of x. It could be the 3 to the power of x. It could be 10 to the power of x. It doesn't really matter. It's just some number raised to an exponent. That's what we mean by exponential. So this is going to have a horizontal asymptote here, like this. And the curve is going to go like that. Something like that, okay? And I do believe that this is the point 0, 1 is your y-intercept, okay? And all exponential parent functions look like that. All of them. Doesn't matter whether that's 2 to the x or 3 to the x. I might even write that. 3 to the x, 4 to the x, 10 to the x, e to the x. You might say, what the heck is that? Yeah, it's whatever, okay? That's what an exponential function looks like. You say, I don't believe you, Mr. Spake. I say, hold on, I'll show you. I say 2 to the power of x. Hey, look at that. Change that to a 3. Hey, look at that. Hey, look at that. I mean, come on. They look the same, right? Okay, they're not the same. Don't think that. They aren't. They are not, okay? Bad. Please don't think they are the same. But they look the same, right? They all have a very similar shape, okay, is the idea, okay? Now, we have an asymptote, a horizontal one, at y equals 0. And I'm going to use a little dash line. And I like making it red. And I like bolding this. Oh, it's already bolded. So you can really see here. And look at this. I'm going to zoom in. Zoom in. And then as I go to negative infinity, that means to the left. Look at that purple line. Look at that red line. I am getting real darn close to that. It almost looks like I'm touching it, but if I zoom in even closer, hey, look at that. The distance between that line and the curve, right? The asymptote is the line, the curve is the graph. It keeps decreasing, right? It's the distance between them is decreasing. And that's actually, I think, the more formal definition of an asymptote. It's not that it just gets close to it. It's particularly that the distance between that line, the asymptote, and the curve goes to 0. Okay? That's a formal definition. Don't worry about that too much. It's just the idea that you're getting close to it but not crossing. Okay? But I say that this not crossing business is false because, oh gosh darn it, what is it? Is it like over x squared or like, man, what is it? I can't remember. There's a particular kind of graph. No, that's not it. Is it 1 over x cubed? Oh, I wish I could remember. We're going to see it. We're going to see it in due time, in the spring. I can't remember what function. It's a rational function, but your graph kind of looks like this. It's like it's gonna look like this. Okay, and that's what it's gonna look like. And it's goofy. And that's complicated, and I don't want you to worry about that right now because that's not what we're doing right now, okay? I mean, this is months away. You're going to know so much more about algebra before we actually tackle that image right there. But there are still asymptotes here, and I just want you to pay attention with how on this left curve it approaches 0 there, and down here it approaches upwards towards 0. And this middle part, which I'm going to highlight in green, it crosses it, but that does not matter, okay? We don't care about that. It's what I highlighted in yellow. That's the defining feature or definition of an asymptote. So I'm going to erase that stuff. Again, don't let that image give you nightmares. We're not dealing with that, okay? We're not dealing with that. Not yet. But we'll get there. And you'll love it. You'll say, I love rational. This is awesome. Okay. The next one is log. So I'll have log x. And you don't know what log is yet, but log is much like exponential. It's actually called the inverse of exponential. And there's a bunch of different logs. Log base 2, log base 3 of x. We have even natural log x. All these different logs. But they all look the same. They all have a vertical asymptote here. Okay, this is a vertical asymptote at x equals 0. By the way, this was a horizontal asymptote at y equals 0. Okay, vertical asymptote at x equals 0, and the graph has an x-intercept here. X-intercept here at 1, 0, and it goes through that point upwards like this. And it looks really similar to exponential, just kind of like if it was turned on its side. Or more... Whoa, did you hear that? You probably didn't hear that, but I just heard massive tire screeching outside my apartment. It scared me a little bit. Okay. So this is my vertical asymptote at x equals 0. And I don't cross this. That image is getting closer and closer to the y-axis. If you don't believe me, type in log x and look at it, right? I'll type in x equals 0, right? And as I zoom in and I go down, right, the distance between those two lines is getting thinner and thinner, right? It really is approaching that thing, okay? And that's my asymptote. That's what that is. Okay? And I mean that's kind of it. That's all I really wanted to cover in this video. Is just what is an asymptote. Stick around for a second if you want to hear about rational. Let me make a new page. I'll make one about rational, because rational has both asymptotes. Exponential only has the horizontal, and logarithm only has the vertical. But our rational function 1 over x has 2. It's actually both of those. It's the vertical asymptote here at x equals 0, VA, and horizontal. It has 2. You can have multiple. If you saw that scary, frightening image I drew earlier, which really shouldn't be all that frightening, I actually had 3 asymptotes. So I can have lots of them. Okay, I can have tons. But right, and this one just has 2. And the rational function looks like something like this. These asymptotes kind of guide our sketch. I know that the curve gets close to these dashed lines, so that's what I use as reference. Notice, with a lot of my graphs, I kind of plot points, right? Like when I do x squared, that looks like lambda squared. If you're at lambda table group, shout out. That's orange, by the way. Or is it? Yeah, that's orange group. Anyway, x squared, which is a quadratic, I would plot points, right? -2, 4, -1, 1, 0, 0, and then I'd make the curve. But with rational, I'm just sketching it with the asymptotes because that's kind of where the graph is, right? That's what determines its shape, really, is those asymptotes. So yeah, this one has 2. Why does it have 2 is one question people have been asking. I did explain this in class, and I tried to make this as clear as possible. I don't know how clear it's coming across, so I'll try it one more time here. It's okay if it's not sinking it, if you didn't get it the first time, it's okay. Sometimes you just got to hear it more than once, or you got to think about it in a different context, something, right? You don't always just automatically understand when something's said, right? That's certainly not true. But what's causing these asymptotes for a rational? Well, the vertical asymptote x equals 0 is caused by division by 0. So I'm actually going to write that. This vertical asymptote is caused by trying to divide. I'll just write the word divide. Trying to divide by 0. And if you don't know what I mean by that, observe, right? If f of x equals 1 over x, what is f of 0? Well, f of 0 is 1 divided by 0. And can I divide by 0? No. No, I can't. I cannot divide by 0. It's bad. You might say, why, Mr. Spake? Why? I I'd like to talk about that later in the year at some point, actually. If you've never had a teacher that told you why you can't divide by 0, there's lots of ways to kind of think about it. I don't really want to do it in this video, though. Okay, it can take some more time, and I do want this to... I'm already going a little long. I think I've been talking like 15 minutes, so I want to try and cut this short. So it's not terribly long. So that's what's causing that, right? When x is 0, you're dividing by 0, that's bad. That's why that asymptote's there, because you can't touch it. You can't cross it. And I know earlier I said, right, like, an asymptote doesn't technically mean you can't cross it, but it is usually what it means, okay? And in this context, it is. You don't cross x equals 0 because you can't divide by 0. It's not possible. It's undefined, all right? The same goes for y. The horizontal asymptote exists, but for a different reason, okay? So this one, and maybe I'll do this up. I'll do it above. Beep, 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 boop, boop, pop, pop. This horizontal asymptote is maybe not caused by, I'm going to say happens because 1 divided by any number is never 0. Okay? This happens because 1 divided by any number is never 0. And now I'm going to do another observation, see? Look. What did I say earlier? If f of x equals 0, right? Then that means 1 divided by x equals 0. And if you were to multiply both sides by x, if I had 1 over x equals 0, and I times both sides by x, thereby kind of crossing these out, I get 1 equals 0 times x, where x is some number. Well, what is 0 times some number? 0 times some number equals 0, not 1, right? 0 times some number is never 1. That never happens. 0 times any number is 0, okay? And that's just a fact to know. So this can't happen either, right? And conceptually, the way I explain this in class is if you took a pie, right, or a pizza, or whatever you like, right, anything you can divide up into pieces. If you took a pie and split it in half, and then split it in thirds, split it in fourth, fifth, and you kept doing that, and you went to billions, and you said, I have a billionth of a pie, you will always have some fraction, some amount of that pie. It doesn't ever really disappear, right? Don't think of this in a realistic sense, because then you're going to be like, well, I have a molecule of pie, right? I have an atom of pie. Well, don't think about it like that. Think about it numerically, right? If I have 1 and I try to divide by bigger and bigger and bigger numbers, I'm getting smaller, I'm getting close to 0, but I'll never touch it, right? I'll never actually equal 0. That's why there's a horizontal asymptote at y equals 0. Okay? And if you don't believe me, 1 over x. I'm going to make a graph. Look at this. Watch what happens as x increases. So you're looking at that left column. I put in 3, it's 0.33. Put in 4, it's 0.25. 5 is 0.2. And so forth. Look at this. Look at all that. Where's it going? Right? There's always something. If I had 60 pieces of a pie, I'd have 0.01666 repeating, right, amount of pie. But I wouldn't have 0, right? I would have something close to 0, but I wouldn't actually have 0. So that's it. That's why. I hope that this does a little bit better explanation as to why these asymptotes exist for rational. Okay? I did get a question earlier also about why is x equals 0 vertical, right? Why is x equals 0 vertical? And why is y equals 0 horizontal? Well, x equals 0 is a little bit harder to explain. But y equals 0 is easy. Because y equals 0 is a linear equation. Y equals 0 is a linear equation. It's a line. It's y equals mx plus b, where m and b are 0. Hopefully you know what y equals mx plus b is. So this is y equals 0 times x plus 0. So plug in values for x, right? If you make a table x, y, x can be -2, -1, 0, 1, 2. Y is always 0. So if I make a little graph of this, I'll do it in black here, I think. Just a little itty-bitty graph. Okay. -2, 0 is here. -1, 0 is here. 0, 0 is here. 1, 0 is here. 2, 0 is here. Connect those dots. Right? It's a red line. That's y equals 0. And there it is. Okay? Why is x equals 0 vertical? More or less just because we say it is. I mean, it's basically the same reason. I mean, I guess you could try to define, you see, y equals 0 is a function, but x equals 0 isn't. That's because of the vertical line test. I mean, x equals 0 literally is a vertical line test, so it obviously fails the vertical line test because it quite literally is a vertical line. But I mean, whoa, look at that. That's something. Is it trying to draw an ellipse? Is that what it's trying to do? Look at that. Ooh, that's going to come in handy later. Sorry, I'm just playing around. I'm a little kid with this iPad. Why is x equals 0 vertical? Same reason. X comma y. If you said this is x equals my plus b, if you could do that, where m and b and blah blah blah, right? X equals 0 times y plus 0. I mean, and you might say, you can do that? I was like, sure, why not, right? I'm just setting up some relationship between x and y. It doesn't really matter. I'm just defining it to be 0. X is always going to be 0 no matter what y is, right? And so all of these values, you know what, maybe I'll use like red or blue. All of these values are the same line. Okay. I'm going to erase this mx plus b thing. We don't ever actually do that. But it's the same idea. Okay? Like, it's just this, it's like the same thing. It's just, it's not a function. Okay? That's why I don't really want to bother writing it that way. It just means for any x value, x is going to be 0, but the y values are whatever. Y values could be anything. So That's why I have these two kinds of lines. Okay. I'm done talking about this. I hope this is helpful. I hope this was informative on what an asymptote is and helpful in your future understanding. Okay. Have a wonderful rest of your night, and goodbye.